This will be one more example on a hypothesis test on proportions. So here's our example this time. Does therapeutic touch exist? Is it possible for a nurse to manipulate a human energy field by holding their hands over the patient? In 1998, this was actually studied. The Journal of the American Medical Association published a paper reporting work done by a 9-year-old. She performed a simple experiment in which she challenged 15 therapeutic touch practitioners to detect whether her unseen hand was over their left or right hand, selected by flipping a coin. So you've got the patients with their hands, they can't see them. This 9-year-old is hovering a hand over one side versus the other, and these people are supposed to determine if they can sense it. Overall, of the 150 trials, the practitioners were successful 70 times. Is there evidence from this experiment that practitioners can successfully detect a human energy field? So let's write down our hypothesis test over here in Excel. We'll organize this nicely for you. And let's see here. So the null hypothesis should be something about what we believe is probably true in the background. So it looks like the 9-year-old was probably trying to disprove that the therapeutic touch actually works. So let's say that the 9-year-old is thinking that your chance of guessing that my hand is hovering over yours is 50%. So therapeutic touch is really nothing more than guesswork. That's what this 9-year-old is saying. Now the alternative would be that the proportion of times that you actually get this correct, if you're trained in therapeutic touch, is actually bigger than 0.5. Okay, so let's look at our particular sample. We've done 150 trials, so that's our sample size. Okay, the assumed mean is coming straight from the null hypothesis, and the standard deviation is coming from that assumed mean. So square root of 0.5 times 1 minus 0.5 over sample size. So we have our standard deviation. Again, we're using this because we're assuming that that's probably true, and if there actually is such a thing as therapeutic touch, then we'll be able to find evidence that maybe disproves this. Okay, so our particular time, we had 70 out of 150, so we had a proportion of 28%. That doesn't seem right because I typed it wrong. 70 out of 150, there we go. 47%. Well, that's actually less. So now let's rethink what's happening here. Maybe therapeutic touch is actually being able to tell whether it's there or whether it's not there. So what if we changed our alternative hypothesis to say something like the proportion's just simply not 50%. They can either tell and they're going to get it right more than half the time, or they're going to get it wrong more than half the time. Well, okay, in this particular case, we're actually below. So let's see what the p-value is of having that happen, or more extreme than that. Now, more extreme would be less than that, or potentially going on the other side. So I'm going to say is normal distribution for our sample with the assumed mean and the standard deviation based on that assumed mean, times 2. Now I'm saying times 2 because I'm saying I want the left side from our proportion down, or the right side, so from the symmetric proportion up. Now that's a very, very high p-value on this two-tailed test. So what this means is that we fail to reject the null hypothesis. In other words, what that means is we don't have enough evidence to disprove the null hypothesis. which really just means to me that, well, we don't accept the null hypothesis as being true, we just currently have not found enough evidence to disprove the null hypothesis. So in other words, if you're really bent on disproving this therapeutic touch thing, well, you gotta go find more evidence for me because we don't have it yet.